Norway has built more than 1,100 road tunnels. That's roughly one tunnel for every 5,000 people. That's unusual because when a road reaches a stretch of water, a bridge looks like the easier option. Crews can work above the surface and place the road directly across the gap. On the other hand, a tunnel creation is a very hard job. Workers have to blast through solid rock just a few meters at a time. Yet Norway keeps building tunnels. Near Stavanger, they are now building Rogfast. This 26.7-kilometer highway will descend almost 392 meters beneath the sea. When it opens, it'll become the world's longest and deepest subsea road tunnel. At that point, Norway's tunnel building starts to look like an obsession. But there's a reason engineers keep sending roads underground, and it has more to do with the bridges they're avoiding. So, why does Norway build tunnels instead of bridges? Well, one Norwegian proposal almost blurred the line between a tunnel and a bridge. The E39 runs 1,100 kilometers along the coast between Kristiansand and Trondheim. Driving the entire route takes roughly 21 hours because you still have to board 7 different ferries. Then the road reaches Bjornafjord. The proposed crossing stretches about 5.5 kilometers, while the water drops roughly 550 meters below. Engineers once studied something called a submerged floating tube bridge. Their design placed 2 concrete traffic tubes around 20 to 30 meters underwater. Crews would cast sealed sections inside a dry dock, float them into the fjord, and connect them. Water entering ballast tanks would lower the tubes into position. Cables running toward the seabed or connections to surface pontoons would stop them from drifting. Buoyancy would carry much of the weight while ships sailed overhead. Norway never moved this idea beyond research. The current E39 plan uses a massive floating bridge across Bjornafjord instead. Still, engineers only considered a highway hanging underwater because building a normal bridge across these fjords creates enormous problems of its own. Those problems begin with the shape of the fjords themselves. Thousands of years ago, glaciers carved deep U-shaped valleys through Norway's mountains. Seawater later filled those valleys, but the steep mountain walls continued far beneath the surface. That leaves engineers with very little shallow ground for bridge foundations. At Bjornafjord, the proposed crossing reaches water around 550 meters deep. Farther north, Sulafjord stretches roughly 7.5 kilometers across, with depths approaching 400 meters. A normal bridge would need an enormous unsupported span. The other option would place its towers on foundations hundreds of meters underwater. Large cruise ships also need enough open space to pass through the fjord. Then you have the North Atlantic wind pushing against the deck. Salt spray keeps coating the exposed cables and bearings. Floating bridges can avoid those deep foundations, but waves and changing currents constantly move their pontoons. So engineers started looking beneath all that moving water. Down there, many Norwegian fjords hide something far more useful, a huge mass of strong rock. That strong rock changes the entire calculation. Much of Norway sits on hard granite and gneiss. Engineers can blast a tunnel directly through this rock and let the mountain itself carry much of the pressure around the opening. After each blast, crews drill long steel bolts across fractured sections. These bolts lock broken pieces back into the surrounding mountain. Workers then spray concrete over the exposed surface to stop smaller fragments from falling. Because the rock supports most of the tunnel, crews often need far less structural concrete than they would in soft ground. Engineers also choose the route carefully. Rogfast crosses the outer section of Boknafjord, where Tusquitandaitum. The tunnel can follow a shallower rock path than it could farther inside the fjord. Once cars enter that tunnel, ships and surface winds can't affect the road, but the mountain creates different problems. Faults crack the rock, and pressurized seawater searches for any opening it can find. Rogfast takes those problems head-on. Norway fired the first construction blast in January 2018. Rising costs stopped the project in October 2019, but the government approved a revised plan, and crews later returned underground. The finished tunnel will connect Randaberg, just north of Stavanger, with Bokn on the E39. 2 road tubes will run side by side for about 26.7 kilometers beneath Boknafjord and Kvitesoyfjord. At the lowest point, drivers will sit roughly 392 meters below sea level. A 4.1-kilometer branch tunnel will climb toward the small island of Kvitesoy. Around 250 meters beneath it, workers are carving out an entire interchange with slip roads and 2 roundabouts. Teams now dig from both mainland ends and from Kvitesoy in the middle. This lets them advance several tunnel faces at the same time. On February 24, 2026, the final blast opened Kvitesoy's first 211-meter ventilation shaft. Norway expects Rogfast to open in 2033 and shorten the journey between Stavanger and Bergen by around 40 minutes. To dig this far beneath the sea, the crews use a method Norway has refined across decades of tunneling. This method doesn't rely on a giant tunnel boring machine. At each Rogfast working face, A multi-armed drill jumbo first bores probe holes into the mountain ahead. These holes warn the team about fractured or weak rock before anyone blasts into it. They also reveal any water-bearing zones. If a probe hole starts releasing water, a computer-controlled grouting rig pumps micro-cement deep into the surrounding cracks. The cement hardens inside those fractures and forms a sealed barrier around the next section of tunnel. Then surveyors bring in laser-guided instruments. GPS signals can't travel through hundreds of meters of rock, so the lasers mark the exact position of every blast hole. The drill jumbo follows that pattern and bores roughly 5 meters into the working face. Crews fill those holes with explosives and move everyone back before firing the blast. Once ventilation clears the air, heavy loaders carry the broken rock away. A geologist can then walk up to the newly exposed surface and check every fracture. Stable sections may only need a layer of sprayed concrete. Weaker areas receive longer rock bolts or thicker shotcrete. As the tunnel takes shape, workers add waterproofing and install concrete panels along the interior. After all that work, the road has only moved forward by a few meters. The drill jumbo rolls up to the new face, and the whole process begins again. Sometimes, though, those probe holes uncover much more water than expected. At one Rogfast worksite, around 330 meters below sea level, water forced its way through fractured rock at roughly 5,000 to 6,000 liters every minute. The pressure reached about 33 bar. Large pumps controlled the flow while grouting crews sealed the damaged zone. This shows why Rogfast's engineers chose drill and blast for the tunnel's changing geology. Workers can pull the machinery away from a dangerous face and inspect the exposed rock. They can then change the support before moving forward. The two parallel road tubes also improve safety after the tunnel opens. Connecting passages will let drivers escape into the other tube if a fire or serious crash blocks one side. But blasting the route only creates an empty space beneath the sea. Crews still have to turn that space into a working underground building. That underground building first needs a way to breathe. Rogfast will use hundreds of jet fans mounted throughout its two road tubes. These fans will push polluted air toward ventilation towers near the shorelines. Two enormous shafts on Kvitsøy will exchange air near the middle of the route. To create the first one, workers drilled a narrow pilot hole through the island's rock. They then enlarged it until the shaft measured 211 meters deep and 9.4 meters across. Groundwater will keep entering the tunnel even after construction ends. Drainage channels will carry it toward pumping stations at the lowest sections. Cameras will watch traffic throughout the route. Electronic signs can direct drivers during an emergency, while cross passages provide a protected route into the opposite tube. Kvitsøy also turns the tunnel into more than a straight underground road. Slip roads climb away from the main tubes and meet at two roundabouts around 250 meters beneath the island. Still, Norway doesn't send every road underground. Nordøyvegen in Morog-Romsdal shows how engineers combine different structures along one route. The complete connection opened on August 27, 2022, linking 7 islands with the mainland. Around 3,000 residents no longer needed the old ferry and fastboat services for their regular journeys. 3 subsea tunnels carry the road for almost 13 kilometers beneath the deeper channels. When the route reaches shallower water, it crosses new bridges and a causeway. Crews even reused rock from the tunnel blasts as fill beneath parts of that causeway. The material they removed underground became part of the road above water, so the same route changes with the landscape. Deep channels send traffic into the rock, while shallower sections give bridge foundations somewhere practical to stand. But even Norway's tunnel engineers eventually reach a limit. Roads need manageable slopes so cars and loaded trucks can climb back to the surface. At Stavanger, the water reaches more than 1,200 meters deep. A normal tunnel following a route beneath it could require an incredibly long descent. That's when floating structures return to the plans. At Bjørnafjord, the current design places a 5.5-kilometer bridge on roughly 40 floating pontoons. Engineers chose that approach because conventional bridge foundations can't practically reach the bottom. Each crossing depends on where the rock runs beneath the water and how ships use the fjord above it. When the mountain offers the more controllable foundation, the tunnel wins. Norway's 1,100 road tunnels aren't just some strange national obsession. Solid rock often gives its engineers a safer and more practical route than a bridge across deep, stormy water. That's why so much of Norway's road network disappears into the tunnel instead of bridges. And if you want more insane construction and the engineering hidden inside the world's biggest mega projects, subscribe to the channel.